I'm still trying to load my page. It's being really slow right now for some reason. Sorry, I'll
Okay, don't worry.
know when I'm.
I know, I live in the countryside. My internet gets slow too sometimes. Just like the other time that you guys were talking and asking me something and I was just not there. Yeah. Okay, I'm opening the quiz. Well, I thought that the material for this lesson was a little harder than last week. I
Okay.
had quite a hard time understanding it, especially at the beginning, because reading in the book, um, I mean, the explanation is after a really long example or something, so I was a little confused.
Mm-hmm.
And I'm not sure how good I'm doing at this, but we'll see.
Yeah, we'll see how the quiz goes, and then I can kind of answer
Yeah.
some of your questions too.
Yeah, I think it almost looked like we skipped a part because it introduced the concept of, you know, like the mean of the mean, you know,
Uh-huh.
in a very direct way, and like it didn't really make, I don't know, it's because it never talked about the fact that, you know, like this thing existed, and you know, you were just dropped into, okay, just do it, you know, on the applet. And so it
Yeah.
was like, what is that, you know? It's like at the end, you know, you figure it out,
Yeah.
but like the way
At the
it's
beginning,
structured, you know, it's like for like 3/4 of the study material, you're just there, like, you know, scratching your head, and it's like, what the heck is that, you know? It's like, but yeah, it's, you know, I got there, but it
Yeah.
took me
Yeah, it's
it
a
took me
little
more than it could have, you know. But yeah, whatever.
Yeah, for sure. I know that can be frustrating. I
guys.
ran into that the first time I took the class too, and just trying to figure it all out.
All right, I got it working now. So it's working for me now.
Okay.
Okay.
Perfect.
Yeah, thanks. So, Gabriel, are you leading the meeting this time, or Danielle?
dang it.
Yeah, he is. It's your turn, Gabriel.
Can you guys hear me?
We can now.
Yeah.
Gabriel.
Maybe we lost him. No.
Yeah, like he lives really like in a small village,
Uh-huh.
and so like sometimes internet connection where he is, it's not really that good.
Uh-huh. Yeah.
Okay, I got you back. Hey.
Hey.
All right. So, Gabriel, if you can lead and if you can start, you know, the sooner we start, the sooner we finish.
Yes, sorry. It just froze for a while.
Don't
I
worry.
didn't hear a word of what you said, Daniel, but I think it's okay. Okay, so first two questions.
I see two
Yeah.
Gabriels either.
What is happening? Okay, I know what's going on. Yeah, something happened.
Can we start from
Okay.
number 3?
Start number
Yes.
3.
Daniel, do you want to read the first question?
Yeah. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the... Oh, just a second, because it's really...
Taking it.
It is. Okay. When the parent population is right skewed.
This is okay. Well,
It cannot be normal. You know?
Yeah, that's what I was gonna say. So it probably skewed right.
I guess it's skewed right also.
Yeah.
Yep.
Me too.
Yep, that's right.
Okay.
Would you mind explaining to us real quick, just like exactly why that might be? Because it makes sense that it wouldn't be normal, because it would be normal only if it was like a normal distribution.
Uh-huh. Yeah, so if it's a small sample size, it's going to follow the parent population.
Okay, yeah. that's what I
Like,
was
so
thinking.
since this parent population is skewed right, and since our sample size is under 30, then let's go ahead and assume that it is also skewed right. But if it were over 30, then we would know that it was approximately normal.
Okay. Makes sense. Good. Thank you.
Uh-huh.
Okay, question number 4. I think I'm gonna read this one. My internet is working. When you're taking a sample size of n equal 100, what is the shape of the distribution of means histogram when the parent population is the right skewed? Well, it's normal.
Yeah.
Yep.
I agree.
You said before.
Mhm.
And the question number 3, I had to think about it because the whole chapter talks about what is normal and it's over 30. So I'm like, okay.
Yeah.
Okay. Question number 5. Isa, you want to read that?
Of course. When you are taking a sample size of n equals 5, what is the shape of the distribution of means? Parent population is normally distributed. I think if parent population, then it would be normal, right?
Mm-hmm. Yep.
Yep.
I didn't hear that. Did you say normal?
Yeah. He said
Okay.
normal.
Okay.
Do you agree with that?
Perfect. Yep.
Okay. Awesome.
Daniel, do you want to go number 6?
When you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? It's always normal.
Yeah.
Mhm.
Okay. Okay, question 7. When would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small. Data are, choose all correct responses. Okay. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right skewed and the sample size is small. Data are drawn from a population that is right skewed and the sample size is large. So I will say all of them beside the third one.
Mm-hmm.
So it's like right skewed and the sample size is small.
Right skewed, big sample. And like first, second, and fourth.
Yeah, that's what I was trying to say. Thank you.
Yep.
I got confused.
It would be the
Oh.
first one, even though it's a small sample size.
Yeah.
Yes. Because anytime the parent population is normal, we know that no matter how small the sample size is, it'll also be normal.
Okay.
Okay. Question number 8. Do you want to read that, Isai?
Which of the following, excuse me, my computer, okay. Which of the following gives the best explanation of the central limit theorem? The population from which the data are drawn is normally distributed, then the sample mean x will follow the normal distribution. For vowel-shaped data, 50% of the data will be within one. So this is obviously 97 rule, right? Number 2. If the sample population is large, then the sample mean will be close to the population mean. Size is large, the shape of the normal distribution. Yeah. Sorry, my computer's being weird. Okay, if the sample size is large, the shape of the normal distribution of sample means will be approximately normal.
I would say it's either the first or the fourth, because like the third one, it's the law of large numbers.
And the second one is already the 68, 95, 97 rule.
Mhm.
So
You know, they're both true, the first and the fourth. You know.
Mm-hmm.
because they're both.
More than one.
No, you can. We have to choose the best one.
Uh-huh.
Oh, best explanation. Sample size.
Yep, so I'll give you a hint. One of them is a rule of the central limit theorem, and one of them is is the definition of the central limit theorem, but is also a rule.
Interesting. Okay.
So the hint says that they're both rules.
Yeah, they're both rules, but one of them is the definition. So this one you might have to go back to the textbook for, and then look for the actual
I
definition.
will guess.
I have it here in my notes.
Okay.
Okay.
If the sample size is large, the random variable x bar will be approximately normally distributed.
So it's the fourth.
Mm-hmm.
Yeah, I was leaning to that too.
Yeah.
So
I was actually going to say
good.
the first one, but
good notes, Izay. Good notes.
Yep.
okay. Daniel, you want to read the next one?
Use the following information to answer the next 4 questions. Let x be a random variable with population mean, whatever. Okay. What is the mean of the distribution of simple means? Well, the mean, it's the same as the population mean, so it's 10.
Mm-hmm.
Mm-hmm.
Yeah, I'll say this.
Yeah, good job. Usually that trips people up pretty bad, so we're quick on that.
Thank you. Okay. The next one, question number 10. What is the standard deviation of the distribution of sample means?
6.
Okay, so the
Divided.
standard deviation is the how do you call the square root?
Square root.
Yeah, square root.
Okay. Sometimes I have a hard time remembering that word. Good. Okay.
So it's like
I'll get in the calculator.
6 divided by the square root of 36.
Yeah.
I think you can do it without a calculator.
There we go. I haven't noticed that. Sorry.
You know, since we're brothers, we tend to tease each other, you know. So it's like,
Oh yeah.
Yeah, we don't do that with all the other members of the class, but
yeah.
That's cool, your brothers. That's
So
funny.
it's just one, right?
yeah,
Yeah.
it's just one. And we're quite competitive, so
That's awesome.
of course you already notice I'm better than him, but it's okay.
Yeah.
Okay, so yeah, it's one.
Yep. One is right.
Okay, question 11. Do you want to read that, Isai?
Regardless of the distribution of the sorry, my computer like things really weird. Okay. Regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape distribution of the distribution of the sample mean? Normal, right?
Yep.
Yep. That's right. Alright.
Okay, question 12. Daniel, you can finish with that.
Yeah. What theorem would justify your response to the last question? Law of large numbers or the central limit theorem? Well, I would say the last one.
Yeah.
No, because the last one is the one that says that it's normal distribution. So
Yeah. It's the one that we read before, also definition.
Yeah,
Yeah.
sounds good.
So we can submit
Okay.
and see what
Yes.
comes up.
Okay, so go to submit this.
It's all good.
Nice.
Yeah, good job, guys.
So now should I click stop broadcast?
Yeah, that's fine.
Okay.
You know how to
Then